Thank you. Hello, everyone. Michael Webb here. I'm a software engineer at Neo4j working on the GraphQL team. And today I would like to talk to you about vector indexes and, of course, GenAI and how that can work with GraphQL. So just a small run through of the agenda. First, I'd like to talk about vector indexes in GraphQL in a general sense, just to introduce the topic. Then I would like to talk about the vector directive, the @vector directive, which is what you use to actually make this work on GraphQL with us. Then I'll go through a little demonstration, and then finally how you can take steps from here and try it yourself. Okay, so vector indexing in GraphQL, a quick overview. Vector indexing is a method of storing and searching through vector embeddings. What is a vector embedding? A vector embedding is a long list of floating point numbers. Here's a very small example on the screen at the moment. It's actually a lot shorter than the real one. The real one is 1,536 dimensions, which can be considered a small amount of dimensions, actually. So a vector is a long list of numbers. And vector embeddings are commonly used to represent unstructured data like text and images. So why do we want to use vector indexing? Vector indexing helps us identify similarities, which can be useful for things like finding related products, similar movies or documents. And that's, of course, useful for powering recommendation engines, useful for natural language processing and content retrieval. Vectors are produced by example, text embedding models, which enables us to do similarity searches with the results with the embedding model's understanding. I'll go through that shortly a bit more. So what makes it useful in GraphQL specifically? Well, GraphQL has, it's very developer friendly, has a declarative syntax, and it makes it easy to specify the exact data requirements from the client side. And especially with GraphQL and Neo4j, it's nice and easy to traverse related entities. With strong typing, with schema-defined types, it ensures consistency with clear documentation of available queries. It simplifies the development process by embedding vector search capabilities into a familiar GraphQL schema. And of course, it exposes the powerful vector capabilities without the need to write custom cipher for every query yourself. That's the big thing. What about GenAI through Neo4j GraphQL? So we can be using the GenAI plugin from Neo4j itself. It facilitates the embedding generation for us, the encoding of the vectors. And we can then therefore query using natural language, like a phrase in English or a natural language phrase. And then we can search through the vectors in our database based on the response from a generative AI API. So the vector directive, which has been introduced to the GraphQL library, let's have a little look at this. What it can do, at the moment, it's a read-only query, so it supports only read. You can't mutate with this, but it can be configured in two different ways. First of all, you can pass a vector directly into the API, so the user would pass the vector themselves. They would have done the embedding generation themselves, or you can pass a query, and then the embedding is done by the API in essence, and then we would query using that. There are some prerequisites to using this though. The database must be Neo4j version 5.15 or higher because it's a relatively new feature. The node vector embeddings must already exist in the database because, as I said, it's read-only. That needs to be done outside of this directive. The vector index needs to be created manually, though we'd provide a way of asserting it exists when we have the server starting up. The embeddings must have been created using the same provider and model, such that if we were using OpenAI to generate these embeddings, these vectors, then we must also use OpenAI to do a query on them. Vector indexes cannot be performed across multiple labels. So if you have movies and actors, for example, you can't search across vectors that are on movies and actors. It'd have to be just movies or actors. And then queries by phrase require the credentials, so we can actually connect to your API for the LLM provider. And I just want to go through really quickly the documentation that we have available for this from the Neo4j GraphQL documentation. So I'm just going to share this tab. So here we have a very small snippet of a longer page, but it just showcases the small necessary required changes to your Neo4j constructor, where we pass in this case, the feature vector with OpenAI, a token, and then the model. But I think it's going to be more interesting if I show this a use case for this. So I'm just going to switch to my code, and we'll have a look at this in practice. One second, please. Okay, so we have, I've got a repo here with an index and a server. So it's a server with the Neo4j GraphQL type definitions first, and then the usage of the Neo4j driver, and then as described before, using Neo4j GraphQL to create this. So the type definitions, we're using the vector index directive, where I described the index that we're going to be used. This relates directly to the index that already exists in the database. That was what I mentioned before about having the index already created. We reference an embedding property. So this is a property on the node itself, which would contain the data that has this long list of numbers. We specify the provider here. In this case, I'm going to be using OpenAI. And then what's nice is we can specify a query name, so the client themselves will be able to query with a meaningful query name. So in this case, search movies by plot. And other than that, we have movie with a title, actors, where actors is themselves a type that they have name. So that's just a very simple test schema here, using the movie recommendations dataset. And then other than that, we're using Apollo server to run this, and I'll just want to show you how it can work. So I'm just going to start this now. So that's the client. This is the server. So I'm just going to start this up. Okay, so I just made a small demonstration of maybe a front end that you could have working with this. And this is real time. And I'll say something like, I remember there was a story where a toy was replaced by a space toy or something like this. I can't really remember. Let's have a look. Right, okay, yeah, correct. It was Toy Story. That was the one I was thinking of. And so we can see I've got a couple of results here, 4 results, and we see the similarity score for each of these movies where we get the title as well. And that's reflected here in the query that I've performed with search movies by plot as described in the server configuration. I pass in a phrase, which is the text I just typed in, and then we request the title and the score. So that's really cool. So that's nice. What about traversing the results? So let's have a look again. I don't really remember what I typed. I think it was like a cowboy toy was replaced or something like this. I don't remember. Here we go. Toy Story. Yep. Maybe the similarity score was a little bit better this time. I'm not sure. But here we can see that I've not only requested the title, but also the actors, their names. So here we see in the results, we have Don Rickles, Tim Allen, Tom Hanks, and Jim Varney, and so on and so forth for the other results as well. So they're sorted by the similarity score at the moment. That's really cool. But what if we're going to even more, one step further? Okay. So space toy replaces cowboy toy, I think. Right. 94 was actually better this time. But in this case, not only have I got the original movie node title, then I traverse across to the actors, I get their names. Then I'm going to go again back to the associated movies of those actors and get their title. So we can see that we get a much larger response with only a few extra pieces in the query. Obviously, I'm adding more as I go. But the point is, it's very simple to change this query and get the results you want. And we see Tom Hanks has very many, many movies. Okay. Now I was going to show the last piece I want to share. How you can try it yourself. So first of all, of course, you'll need to use the GraphQL library. Then you'll need to have a database, the Neo4j database with the GenAI plugin enabled. If you use Neo4j Aura, which I recommend, this plugin is enabled by default, and that's what I used for this demonstration. And then if you do want to look a bit more into what different configurations are available for GenAI in terms of the plugin and so forth, and which we support in the GraphQL, the type definitions, the different providers are available in this documentation for GenAI integrations. And then other than that, we have the recommendations data set, which I used for this example. It's quite a large data set, and it's very interesting to look around that one. And finally, I would recommend using a separate embeddings for this recommendation data set, though you can get the embeddings version from here. It's probably better to do a separate embeddings and run those yourself. And that's it. I hope that was interesting. I hope you have a look yourself and try it out and see if you enjoy it. Thank you very much. I hope there's maybe some questions for me to answer.
Hi, my name is Oleg, and I'm very, very happy to be here at the Nodes conference. We're going to talk about developer productivity for GenAI applications and how application developers can think about building applications with AI components inside, and what do you need to know and learn and think about to have a good setup where you can take them through production, but also don't forget all the lessons that we learned from the normal application development, which is where our expertise lies. Right. My name is Alex Schleif. I work at Docker. I'm on the DevRel team, and my focus is usually developer productivity, a little bit of test containers and integration testing, and lately AI topics as well. You can reach out if you want to talk on any of those, and I think we can have a very nice conversations. So let's talk about AI. What is AI? Well, AI is not a thing, right? AI is a direction. It's an area of research, and it comes with smaller subsections. So when we talk about building something into applications, right, not using services where we very easily can go around with hand waving around particular topics, like implementation details. When we need to build with a thing, you need to be more precise. Your understanding needs to be more precise. So AI is a direction, and currently, most likely, direction of AI is going to be machine learning as a discipline. And the particular implementation of that is the deep learning with neural networks, algorithms, with particular infrastructures that allows deep learning at massive scale, and that was enabled. That enabled us to create large language models. And large language models is the technology that we currently sort of use and assume when we talk about AI. So this is what we're going to build into applications. We're going to talk about how to use language models in our applications to implement parts of functionality that we would like to see in there. It is very interesting because it gives you a very different perspective on AI, and it gives you the actual functional or non-functional requirements, what to think about, because from this fuzzy term AI, you get a very technical implementation thing, a model that takes input to the text and outputs you text as well, and that gives you some limitations and some abilities. So this is AI. We're going to talk about language models. What is productivity? If we talk about developer productivity, it's very often considered a fuzzy subject, but quite a bit of research was done to enable us better understand what are the productive environments. And so the recent research that resonated with me very much is that particular paper from Microsoft and the universities about what are the core pillars of developer experience. There are many things that makes developers productive, but in the nutshell, everything that is good or bad in developer experience fits into one of the three main areas. There was a feedback loops where you need to get the results of and understanding whether you are doing the right thing or whether you're doing the thing correctly. The faster, the better. Slow feedback loops makes unproductive environments. It's cognitive load, which is how much you need to keep in your brain, in your head, when you are actually making changes to your applications. It includes the complexity of the applications, the complexity of the infrastructure, the ability to actually like go and see the application in action, or down to like small details like programming language syntax. Obviously, if you can have less cognitive load, you can be more productive because you can think about the actual important things rather than small pieces. And then, of course, the flow state. If you can get into working without interruptions, your developer experience sort of increases. It's much, much better, right? You can make progress in small increments going forward towards the goal. And then this is how you get lots of work done. If you get interruptions, if you need to distract yourself with mundane tasks for whatever thing that you're working on, then it will be very, very hard because you need to restart the context in your head all the time, which is multiplied by the amount of cognitive load that you need to have. And then those three, feedback loops, flow state, and cognitive load, kind of sort of are the core pillars of this. This is what we mean. We want to have a setup where we build applications and AI into applications, and we have decently tight feedback loops, less cognitive load than as little cognitive load as possible on the infrastructure details, and just be able to work on this normally to stay in the flow state. So AI should not be different, right? It's just another technology that developers should master and use accordingly. So luckily, there is the recent commoditization of AI technologies enables us to do very, very many things without specific knowledge or experience. So there are two groups of people, two roles that were in the past different people. So application developers who are building applications, working at normal application shops or enterprises. They use normal standard enterprise grade languages that are popular in such ecosystems like Java or .NET or Golang. And they build applications. They have already applications. They have already quite a bit of data they have in the applications. And those are well, I am those, right? And I think there are very many millions of application developers in the world. And now we have also the AI developers, the machine learning experts, people who are very, very proficient and put a lot of time and education and effort into learning how to create AI components. They can train models, they can fine-tune models, they understand the machine learning at a much deeper level than an average application developer would. Very often, their ecosystem of choice is Python, both for the tooling and the simplicity of using it, and their artifacts, right? AI components are the output of the work. They have the same, very similar to the DevOps cycle. They have the ML ops processes, right? But instead of building applications, they are building AI components that application developers can use. So the thing is, now those worlds are getting closer together, and application developers become more and more responsible for some of the tasks that AI developers were doing, and also consume their artifacts and outputs natively. So that means that very, very soon, everyone will become an AI developer. Applications will start using AI at larger scale, not necessarily exposing them to the end users, right? I'm not saying that that you need to get and start building chatbots or providing user input directly into your LLM. No, but a lot of functionality can be represented by an AI component. You can predict credit card flaws and fraud with the AI component. You can non-deterministically build recommendation engines, and all the other tasks that were previously left to the specifically trained machine learning teams. Now application developers can use that, because now we have very powerful solutions that based on LLMs that can encode fuzzy tasks as prompts, right, as natural language. So everyone will become the AI developer, and applications will have, sooner or later, right, we will have some parts of functionality that are not written line by line in code, but are created by training or fine-tuning a model, or using a model in a particular way, coding it by giving it a particular prompt, and getting responses not for the end user to see, but within your application to use for something else. So the invisible AI, so to speak. How do we do this now? How do we build applications when parts of that is AI, or in the current spiral of the AI development, the large language models? Well, we know how to build applications. This is the DevOps cycle. Whether you're following it consciously or not, you need to build your application, you need to test it, you will need to operate that in production, you'll need to monitor for things, and then it goes again and again. If some of the components are now not normal code, not normal artifacts, if you, for example, my experience is mostly Java, if those are not Java applications, but AI models, how does my DevOps cycle changes? Everything becomes very much tainted by AI, in a sense that all my processes need to accommodate for this. So let's think about how it works, right? First of all, our models, large language models, become software, right? So what we need to do, we need to ensure that we treat them as software components. That means that we need to take care of hallucinations, we need to do some testing, we need to ensure that models can be used within the normal software cycle. The answer, if you're using AI, is mostly that there will be non-deterministic outputs, and you need to deal with that. And it's very, very hard for the normal application development worldview to deal with randomness. We almost never usually have that. And now it's a native part of our experience if some parts of the application are non-deterministic. So how to deal with hallucinations? Well, the usual answer with dealing with AI is you will need more AI to solve problems with the previous AI. And it's not as bad, because like it's not an endless loop. It's not turtles all the way down. But if your outputs are non-deterministic and you want to have any control on that, you need to either employ statistical methods, or you need to verify that the output is what you expect, with something that understands natural language of the output. So how do you deal with hallucinations? Fairly simple, right? What we can do, we can use other language models with specific tasks of proving the factuality. So the bespoke models, for example, are a good example for what's called grounded factuality. You can give them a document, and you can give them a claim, and you can ask it whether the claim is supported by the document. This is a much smaller task than predicting the output as an answer to a random arbitrary question, and employing a model to fact check the output of your other LLMs can be a very, very helpful and useful task. It's extremely, extremely important for the retrieval or augmented generation patterns, where you can get additional information as the form of your documents, right? And then you can check the answer, whether it is actually supported by the information that you already have in your relational database or in your previous application knowledge base. Can be anything, can be a graph database, can be relational database, document store, anything. But you need to verify the responses. So it's hard to do using normal tests, but you can use particular specific models. You can also, of course, expand that to testing just normally, right? And what you can do with testing is use exactly the same approach. For your local environment setup, for your tests, you can create more agents, more LLMs, and use them in your normal application unit tests or integration tests to verify that the answers that your AI component gives you actually are along the way of thinking. This is very, very hard to do otherwise, and the LLM is there to the rescue. The same thing happens with other things. For example, when your models start becoming software, you need to think about things like, for example, security. If there is a component in your system, it can be exploited. And then it's very fuzzy with LLMs as well, because you're going to feed textual data to them. And that means that the user very often can influence that quite a bit. For example, you're building a recommendation service for movies, and you would like to fill my biography or my profile information into the recommendation service to learn what I like, right? Well, my biography, my blurb about what I like can contain malicious instructions, and your prompt will be will just become poisonous and injected and tainted, right? How do you deal with that? It's very, very hard, because again, the input to LLM is text, so it's hard to work with it using normal tools. And the answer to that, you probably need another LLM to check. So what you do for security, as a typical current understanding of a good approach, you probably need to have another LLM to check the prompt that you're giving to the powerful one, and configure that with the instructions to just give you a number in return, whether the input is malicious or not. This is a much robust approach than just giving it to your all-powerful, all-data-having LLM, and you can use it as a simple component within your application before you use the big one. Interestingly enough, that also means that your AI usage will probably grow as soon as you start using AI. Like you want to create a task for something small, and then you suddenly need other things. You need testing for the fuzzy thing. You need to think about security. You need to think about the input transformations, the prompt transformations. You need to think about maybe the checking the output after the fact, and that becomes a much harder setup. However, it's doable. So you need to think about non-deterministic security at least when your models are being used as software. And now the inverse of that, right? If you write software by using models, what do you need to think about as well? Well, the first one is the prompt engineering. Prompt engineering is, despite it's kind of sort of sounds funny, it shouldn't be the real engineering, right? But it is an area of expertise, and it's something where you can learn how to build your application prompts better for your specific reason. There are two things to think here. One is there are actual proper techniques that you as an application developer, you don't have to become an expert, but you can learn what some of the best practices. For example, what you want to provide, you want to definitely provide the output format schema to you in your prompt. So your AI doesn't use input text and output as just random text, because that is the silliest API surface ever. We know that we want structured input and structured output. So you can provide schema, and it's almost always a good idea to have schema in your prompt to make your AI components conform to that. You almost always want to use the few-shot prompting, where you give the examples of the inputs and the outputs to your AI in a prompt to show it how you want to format the input and what the input should be for those particular scenarios. It's almost always improves performance on the particular tasks by quite a bit. And also, right, if you're using any application framework, you will probably write your prompts and it will sit next to your code. Is that a good idea? Well, not always, right? It's very, very hard to understand this, but the companies will probably decide what models to use, not based on the individual application needs, but based on the macro company factors. Like, for example, what cloud provider has the cheapest, or which models they can train in-house and deploy them at scale. It will probably not be your application-centric decision, which is regrettable if your prompts are with your code, because those decisions can be made separately. And after a fact, if your company switches from one model provider to another, or even if the model provider of the managed AI just switches the implementation, you need to redo the prompts, or you need to edit the prompts. If your prompts are in the application, that means redeploying everything. That means running all the cycles, tests, and everything. If your prompts are externalized in a central repository or in a central configuration server, it's much, much easier. You don't have to have a prompt engineer expert on every team. They can be a central task force within the company, and it might be much, much easier time to switch things. So externalize the prompts, give the examples of the few shots, and try the output schema. There definitely will improve your experience with AI. And of course, you need the evaluation. We cannot run things without tests, right? Applications, we like all the demos that show like, oh, this is how you build things with AI. It's not enough. You need to have a reliable system of predicting whether things still work like 6 months later, 10 years later, because otherwise this is not a production level enterprise system. How do you do evaluation in normal software? You use tests. How do you use evaluation for the machine learning systems? You use statistical methods. And of course, you will have to probably learn something about the tools. One of the that I like in particular currently is Ragus. Ragus is the framework that allows you to specify your sort of golden inputs and outputs pairs for your system, the examples of inputs and the examples of outputs, and then you can statistically mix and create the test suite, evaluation suite for your component and run them in your CI service. You can run it locally as well, of course, and it gives you a very interesting framework what to think about when you need to do testing and understand the evaluate the sort of performance of a model. You need to understand faithfulness and how relevant the answers are to the actual questions, and you also need to verify the precision of and recall of the context. Can it find the all relevant information in the set of information that you have, and does it find like random nonsense facts as well? Those things will give you a better understanding whether the model works than just the gut feeling, or just then like a common approaches that application developers will come up with without machine learning experience. So there are other tools like that, but Ragus is one of the examples where they explain it as well. So you can probably take a look at that. And of course, when you evaluate the models, the next step after that is to maybe try to fine-tune it. Fine-tuning the model is changing the layout, the structure of the model, or changing the weights of the model to be more better performing at the certain tasks. How do you do that? Well, normally you need to probably use machine learning techniques, but luckily with this AI development in the world, we have now more application-centric tools to do fine-tuning as well. One of them is the Instruct Lab by Red Hat, and this is the whole system that you can load your model in. You can create a certain knowledge base using a particular YAML format, and then run the simulations and run the training to append and change the layout of the model to add this new information to the model. And then this is very useful. You will not do that with your relational data in the database, that it changes all the time. But if you have specific domain knowledge that will not change, it's very often much more useful to fine-tune the model, the base model, to get that information once into the model than to run appending that to the prompts at all times. You can run it locally, you can run it in the cloud, of course, and this is a much more developer-centric tool, which requires you just to create certain files and run certain processes for considerably better results than otherwise you would have probably with just trying to figure out machine learning libraries and writing Python code to train the model on your own. So take a look at that as the next step when you're just using models. And then you, of course, need to think about the infrastructure. Very often when we talk about AI, we are talking about the managed solutions that are the clouds, right? We can run AI in the cloud. What's easier than adding the key to OpenAI to your application properties and then running that? There are many of those. Like there is Vertex AI Studio, there is GitHub models, there is AWS Bedrock where you can host other models as well. There are other specific startups and companies that provide you with different managed solutions for the cloud, like Cerebras, which have their own custom hardware, and then they run. Right. Kevin said lots of us are doing fine-tuning training. Don't coddle us. Kevin, there are many application developers in the world, and I can guarantee you that the majority is not doing any fine-tuning on the models. So good for us, but yeah, I think for the general public, this is definitely not yet the reality. But I didn't want to offend or like minimize experiences of people who are doing parts of the ML ops within their circles. Right. So managed solutions, is it enough? Very often it is enough, but what we learned from the past experience with databases and other services is that you need to be able to run your stuff locally for developer experience. So you need to have some sort of local solutions. You need to run models locally. There are multiple ways to run this. You need an inference runtime. One option is Llama, which is a native application that you can run it. There are other ways to run models natively via. There are a ton of projects for that. There is like TGI, there are Llama CPP, there is BitNet by Microsoft. But there are local solutions that you can run, load the model in, and run the inference on your local resources. Why is it important? Is because there is the small LLMs, right? The small large language models that can be more useful for particular specific domain specific tasks, but also more appropriate for local usage, right? The more specific your task is, the better probably you will get with using a smaller model. If you separate evaluation from actual performance model, your production model, you can enable the race to the bottom, right? You can check how the model performs, and if it's up to your expectations, you can dump it down and use a smaller model and a less capable model and check whether you're still within the evaluation criteria, right? So smaller models you can run. Smaller models you will probably be able to run locally. You still need to remember the environment parity from DevOps, right? We want our production to be as our CI. We want our development to be as our CI. So there are slight changes. If you use very capable production model, you probably, for some scenarios, want to test and use it against that in development and CI as well. But for a lot of smaller models, or if you are not using the managed solution, you can run things locally. For developer experience, of course, you can run things in containers just as any other technologies. Whether you're using test containers or not, you can just run the model, put the inference engine into a container, run the model in there, give it access to GPU, and run it as a part of your normal application setup. With test containers, you can run it from the code, making your tests isolated and self-contained. And it's a great way to run your model and application there. Now, we have just a minute for this. So I'm going to skip very quickly through the application architecture, right? You can have very long context windows, which is the normal way of using it. The simplest, you just add everything to the prompt and it runs. You have the RAG, which is the retrieval augmented generation, where you supplement that information with additional data that you have in the documents. And you can go all crazy with this, the full AI sort of setup, where you have different components for embedding and retrieval and post-processing and pre-processing, and your infrastructure becomes incredibly complex right off the box. So the guide to productivity with applications using AI. Remember, you will probably need to embrace AI in the applications. You will need to learn the basics of ML ops, and AI is normal component in your applications, and you probably are better to use it the same way as you're using databases or message worker or cloud. And this is where it will become. It will be the reality very, very soon, in maybe a couple of years tops. Personal prediction, don't quote me on that. Thank you very much.